Good morning, everyone. My name is Kavin Yunaidi. I'm from class 10 IPA. Today, I'm going to show you guys, or I'm going to explain to you guys about Newton law of motion. First, let me share my screen first. Newton law of motion. So there are actually four forces known in the universe, four common forces known in the universe. The first one is electromagnetic. Electromagnetic is the force that caused from electric and magnetic interactions. The second is strong nuclear. It is the force that is responsible for holding nucleus together in the atom. It is the strongest force and it acts over the shortest distance. The third is gravitation. Gravitation is the weakest force and it acts over the longest distance. As we know, gravitation is the force that keeps us standing straight like this. Without gravitation, we will just float everywhere. And the last one is weak nuclear. It is responsible for radioactivity in atoms. So let's get into the history of Sir Isaac Newton. So Sir Isaac Newton is an English scientist and mathematician that is famous for his discovery of the law of gravity. Also discovered the three laws of motion. Today, these three laws are known as Newton's laws of motion and describe the motion of all objects on the scale we experience in our everyday lives. So there are actually three laws that we will study here. So the first one is the first law of motion, or we can also say is the law of inertia. Law of inertia refers to the tendency of a body to remain at rest or to continue moving. The potential of a body to resist from any sudden change in motion. So we can also say that the first law of motion states that a body to remain at rest will remain at rest and a body in motion will continue moving at a constant speed in a straight path unless an outside force will act on it. For example, actually, what does this first law of motion or law of inertia mean? So basically, an object will keep doing what it was doing unless acted on by an unbalanced force. So if the object was sitting still, it will remain still or stationary. But if it is moving, or example like you're riding a bicycle, it will keep moving. So it takes force to change the motion of an object. So as I said earlier, a body to remain at rest will remain at rest, and a body in motion will continue moving at a constant speed unless an outside force will act on it. So example like this. A man is riding a bicycle, but he tripped on some kind like a brick or a box. And then when before the bicycle is moving, but there's a force of the brick that caused the bicycle to stop and the man just fell forward like that. So what are the examples in real life situation? So imagine have a ball. A soccer ball is sitting at rest. Before, if you don't do anything to the ball, if you don't give any motion to the ball, it will just remaining at rest. So it will just sit over there and it will not do anything. But if you give a kick or if you give them a motion, it will just uh, it will move. So it will move from one place to another. The second is the tug of war. So two teams are playing tug of war. They are both exerting equal force on the rope in opposite directions. So because the force are equal within the right team and the left team, so there are no change of motion except there are four% at the right and 3% at the left. So you already know between those two teams, the team with 4 people will have greater power than the team with 3 people. So there are no equal force, except we are giving more force to the right or left team. We jump to the next law, or the second law of motion, the law of acceleration, or we can also say that it is the law of acceleration. So law of acceleration is the net force of an object is equal to the product of its mass and acceleration, or F equals to ma. This is the equation. So F net equals to m is mass, and a is acceleration. Or we can also say that acceleration is directly proportional to the net force, but inversely proportional to the mass. So you can imagine that the equation is like this. So sigma F equals to m times a, which is F is force, m is mass, and a is acceleration. What is actually acceleration? Acceleration is an unbalanced force causes something to accelerate. So a force can cause motion only if it is met with an unbalanced force. So without acceleration, a force cannot cause motion, and a force can be balanced or unbalanced. Depends on the net force acting on an object. So you must be thinking, what is net force? So net force is actually the sum total and the direction of all forces acting on the object. Example, I have like that tug of war. So we need to count between the force that is acting on the right team and acting on the left team. So we sum it to a total that is called net force. So as you can see here, A is acceleration. Acceleration is directly proportional to sigma F divided by m, while sigma F is 0. So A equals to sigma F over m. Or the equation, this is the right one, this is the main equation. Sigma F or F net equals to m times A, which m is mass and A is acceleration. So what is the unit of F? The unit of F is Newton. Newton equals to kilogram times meter over second squared. So this is the unit of F or force. So what does F times ma means? So force is directly proportional to the mass and acceleration. So imagine you have a ball of a certain mass moving at a certain acceleration. So this ball has a certain force. Now imagine we make the ball twice as big and also double the mass, but keep the acceleration constant. So FMA says that this new ball has twice the force of the old ball. Now imagine that the original ball moving at twice the original acceleration. So F equals to MA says that the ball will again have twice the force of the ball at the original acceleration. Okay, there are some other more examples. Imagine that you have what do you call this? A tank, a large tank, and a small car. So as you can imagine, a tank have a bigger mass, have a larger mass than the small car. With a larger mass, you will produce a small acceleration. But with a smaller mass, you will achieve a larger acceleration. So yeah, larger mass, smaller acceleration. Smaller mass, larger acceleration. So it's like that. Okay, here we come to the sample problems. So a 50 Newton applied force drags an 8.16 kilogram log to the right across a horizontal surface. What is the acceleration of the log if the force of friction is 40 Newton? Here is the picture and here's the answer. So how do we find it? So there's a 50 Newton force that drags the log and 40 Newton force that is the friction force. So what we do is we find the F net. So as we know, F net is the sum of the all force. So 50 Newton minus 40 Newton equals to mass times acceleration. So the mass we already know at the problem, so 8.16 kilogram, and A is the one that we find. 50 minus 40 is 10. 10 equals to 8.16 times A. A equals to 10 divided by 8.16, and the answer is 1.3 meter per second squared. The next sample problems. An elevator with a mass of 2,000 kilogram rises with an acceleration of 1 meter per second squared. What is the tension in the supporting cable? So here's the picture and here's the answer. So in this elevator, there are two forces that are doing their job. So the first is the tension of the cable, and mg. Mg is the weight of the total weight of the elevator. So T minus mg equals to ma. T equals to ma plus mg. So we are finding the tension. T equals to 2,000 times 1, m times a. So m is 2,000, as you can see here, elevator with a mass of 2,000. A acceleration with an acceleration of 1 meter per second squared, plus m, also 2,000 times g. G is the gravitation force that we know is 9.8. So 2,000 times 1 is 2,000. 2,000 times 9.8 is 19,600, and 19,600 plus 2,000 is 21,600 Newton, because Newton is the official unit of the force. The next one is how much force is needed to accelerate a 1,400 kilogram car 2 meters per second. So it's actually easy. So you just need to put the main equation. So we are finding the force F net, and then the M, the mass is 1,400 kilogram, and the acceleration is 2 meter per second squared. So 1,400 times 2 equals to 2,800 kilogram meter per second squared. So as we know, kilogram meter per second squared equals to 2,800 Newton. Yeah, just like that. So the next one is, what acceleration will result when a 12 Newton net force applied to a 3 kilogram object? So as you can see here, 12 Newton equals to 3 kg times 4 meter per second squared. So they are asking us about the acceleration. So you just need to divide 12 divided by 3, it is 4 meter per second squared. The next one, a net force of 16 causes a mass to accelerate at a rate of 5 meter per second. Determine the mass. So determine the mass. So you just need to divide again 16 divided by 5. So it's 3.2 kilogram. It's that easy. Next one, how much force is needed to accelerate a 66 kilogram skier? One with acceleration of 1 meter per second squared. So you just need to multiply it, and then it will give you 66 Newton or 66 kilogram times meter per second squared. What is the force of a 1,000 kilogram elevator that is falling freely at 9,000? So they give you a mass and they give you an acceleration. So we need to find the force. We just need to multiply it 9.8 meter per second squared times 1,000 kilogram. So it will be 9,800 kilogram times meter per second squared, or as we can say, 9,800 Newton. The third law of motion. So the third law of motion is actually easy. We can also say that the third law of motion is law of interaction. So law of interaction is they state that for every force acting on an object, there's an equal force acting in the opposite direction. So imagine you are sitting right now. You're sitting down at a chair. So gravity is pulling down on your seat, but the Newton third law says your seat is pushing up against you with your equal force. So that is why you're not moving, and there is a balance force acting on you and your gravity pulling down. Your seat is pushing up. As you can see here, F action is equals to F reaction. As you can see, like this. So what are the examples in our real life? The first one is, of course, skateboard. So when you are standing on a skateboard and you push yourself through the wall, your skateboard will just move forward. But the motion when you push the wall is going backward. So the action that you made, pushing, will become the reaction of the skateboard will move. So because you pushed on the wall pushed you back with the equal on an opposite force that caused the skateboard will move. Next one is stubbing your toe to the ground. So actually, when your toe exerts a force on a rock, the rock exerts an equal force back on your toe. So when you stamp harder to the ground, your toe will become hurt, right? But when you stamp more harder, you the harder you stamp the ground, the harder your toe will hurt. The more your toe hurts. So yeah, action equals to reaction. The next one is, of course, bird. So consider the flying motion of a bird. A bird flies by use of its wings. The wings of a bird push air downwards. In turn, the air reacts by pushing the bird upwards. So the bird just push their wings downward, and the force of the air just making them fly upwards. Yeah, action reaction force pairs make it possible for birds to fly. It's also the same with fish. As you can see, consider the propulsion of a fish through the water. So a fish uses its fin to push water backwards. In the turn, water reacts. The difference between the bird and the fish is the force of the bird is going upwards and downwards, but the fish going forwards and backwards. So it's just the same. The birds flew with wings, and the fish with their fins. Okay, here we come to the sample problems. So the diagram below shows a particle acted on by a set of force. Given that the particle is at rest, find the value of P and Q. So as we know, if we look at the diagram, 50 Newton is equal to the P Newton, and 5Q Newton equals to 3P Newton plus Q plus 10 Newton. So you can see here. So P Newton equals to 50 Newton, as you can see, it's the same. So P equals to 50. And then 5q, you see 5q is equal to q plus 10 plus 3p. And then we input the p 50 to the p over here. So 5q equals to q plus 10 times 3 uh, multiplied by 50. So 5q equals to q plus 10 plus 50 times 3 is 150. We move q to the left. 5q minus q is 4q. And then 150 plus 10 is 160. 160 divided 4, so q is 40. So we got the answer, p is 50 and q is 40, just like that. The next one, given that the particle in the diagram is moving with a constant velocity, find the values of p and q. As you can see here, so it's the same with before. 2p plus q equals to 25, you see here. So we need to do elimination with 3p minus 2q equals to 20 and 2p plus q equals to 25. So we need to multiply this by 2 so that 2q will be the same. Minus 3 plus 4p equals to 7p, 20 plus 50 becomes 70 and p equals to 10. And then we input 10 to the p over here. Q equals to 25 minus 2 times 10. So q equals to 25 minus 20. So q is 5. Yeah, just like that. So thank you for listening this explanation. Sorry if there are any wrong words. See you next time.